Saxon Algebra 2, lesson 121. Students, it's our last lesson of the year. How sad. Don't you wish we could just keep going all summer? No, none of us wish that. We all have earned a break. All right. We have been graphing inequalities. This is another lesson in that. First, we were doing just plain old inequalities. Then we were doing like the three-parters where you have to adjust the algebra on all three sides. We've been doing absolute value inequalities. And then we were doing quadratic inequalities where we had two binomials times each other. This is a variation on the quadratic inequalities. And it's going to set us up where we make the positive, negative, negative, positive, that whole column thing. I'll explain as we go, but it's tying into all of that. Let me show you an example. Literally. Rational inequalities. Remember, this word is a trigger that it's probably going to be fraction related. Because a ratio is a fraction. Oh, weird. Okay. So we're supposed to graph this, and it looks like this. 1 is less than or equal to . Oops, the reals. Oh, I ran into trouble there. This is what we have to graph. It's a flipping fraction. What the heck? How are we going to deal with that? Obviously, you know me by now. We're going to destroy that denominator. There's just no way that we're going to do that. Before we start, though, I notice there's an x. There's a variable in the denominator. And so I need to make sure that I never let that turn into a 0. So x minus 4 cannot equal 0. Agreed? And so x, if I add 4 to both sides, x cannot equal 4. This is part of our answer because we cannot let that thing frickin' turn into a 0 because then the kingdom blows up and the kingdom's gone. So I don't even know what would happen. But anyway, okay, so we know that the best way to get rid of a denominator is to multiply both sides of the equation or inequality by the denominator, and then we can cancel, right? So we would like to do this. But because this is an inequality, that raises a potential issue. Because what if x minus 4, whatever that is, we don't know what the actual number is yet because we don't know what x is. We're solving for that. What if this was a negative number, right? Like if we let x equal 1, then x minus 4 would be negative 3. And if we multiplied by a negative number, then we would have to flip that, right? So we don't want this to ever be a negative number because we don't want these to be a negative number because then we would have to flip that. So how can we do that? Remember that any... Let me just write it and then I'll say it. Any negative number that's squared is guaranteed to be positive. So what we're going to do is instead of multiplying it by the denominator once, we're going to multiply it twice. And I'm going to write it out both times. So this kind of got in the way. Oh, and it's in the way over here too. But we're going to multiply it by the denominator squared so that we're guaranteed that it's positive, and then we don't have to fool around with this. All right? Now, let's look at the right side first. There's the denominator. There's 2 that I multiplied by. One of them cancels. Okay, that's fair. Over here, we're going to have to multiply that binomial by itself. Luckily, we're really good at doing that now, and I know it's going to be x squared minus 8x plus 16. Then we have to multiply all that by 1. Okay, that's easy. I'm doing nothing. And then here, those two cancel. And we're left with this times -1. So I'm going to write negative x minus 4. See how we dealt with that drama, potential drama, by multiplying it by 2 times the denominator. So because we know that will be positive. Okay, now we've got this. Let's clean up this side. X squared minus 8x plus 16 is less than or equal to minus x plus 4, right? We distribute that. Then we're going to need to add x, and we're going to need to subtract 4. We'll swim everything over to the left. X squared minus 7x plus 12 is less than or equal to 0. Both of those cancel. Oh, this is starting to look like one of our quadratic inequalities, right? That's right. Now what we're going to do is factor this. Thank you, Jesus. We can do it by inspection. 2 numbers that multiply to 12 and add to minus 7. Right? Now we're just doing our quadratic inequality game. These 2 things need to multiply to a number that's less than 0. So that means we need a negative number. So either the first one's positive, the second one's negative, or vice versa. Which I say only ironically. I used to have a teacher somewhere in high school that used to say vice versa, like non-ironically. Please stop, right? Okay, so now we go to our list thing. We'll put the plus minus there and the minus plus there, and that relates to these in order. So in this one, we'll have x minus 3. We want it to be a positive number, so it's greater than 0. And then we want the second one to be negative, so x minus 4 is less than 0. Oh, and I need the equal signs because I just copy whatever the original problem had. All right, now over here, the first one's negative, so I want x minus 3 to be less than 0 or equal to. And then x minus 4, that's got to be positive, so greater than or equal to 0. From here on, the problem is exactly the same, in case you were wondering. All right, so now we'll just do a little algebra here. X is greater than or equal to 3, and x is less than or equal to 4. And x is less than or equal to 3, and x is greater than or equal to 4. Domain is the reals. And okay, I was just looking at the answer. Okay, is there a number that is less than 3 but greater than 4? No, this is the crazy side, right? This is the side that makes sense. A number can be greater than 3 and less than 4. And at first we think, okay, solid dot, color and in between. But do you remember this? We said x cannot be equal to 4. So that means we have to leave that one open because it can't be 4. The 3, it's allowed to be 4 based on this answer, but not on that answer. So we have to abide that. And this is our final answer. Woohoo! Okay, so what we learned that's new is that to eliminate the denominator, but to protect us from negative numbers, we square the denominator in order to cancel it. And then that leaves us with lots of leftover drama pieces, but that's okay. We can handle leftover drama. We're all about that leftover drama, aren't we? Ready? One more. 121.2. Graph m minus 2 over, you guys, this is our last example of the year. I expect you to be wiping a tear. Look, I managed to spell reals right this time. Big improvement. We also have to set up our limitation. M plus 2 cannot equal 0. Swim the fish. M cannot equal minus 2. Okay, good to know. Before we draw our picture, we have to remember to look at that. Okay, so what we want to do is we want to multiply this by the denominator squared so that we can cancel, but we know it's going to be positive. So over here, I'm going to do m plus 2 times m plus 2. And over here, I'm going to do the same. Some people like to just write, instead of writing the binomial twice, just write it once and write squared. But I like to do it like this. It just helps me remember what I'm doing a little better. Here, those guys cancel. Now we have to multiply m plus 2 times m minus 2. Let's see if I can do that in my head. M squared. Ah, this is a difference of 2 squares, isn't it? Remember this? I've got this pattern, right? So I know that when I multiply those, I'm going to get m squared minus 4, because it fits this pattern. Does that make sense? And then over here, I'm going to get this monstrous beast. I'll do that, and then I'll multiply it by 2. This is m squared plus 4m plus 4. All right, so I squared the binomial in my head, and I still have to multiply it by 2. This one, I squared those 2 in my head, recognizing it as a difference of 2 squares pattern. If you want to multiply these out the long way, feel free, but at this point, we have done enough factoring by inspection that most students have learned to reverse it and multiply them in their heads. And you guys are both good at mental math, so I'm expecting that you're fine with that. All right, ready? Now we have to multiply this. So m squared minus 4 is less than or equal to all of that. Then let's drag these guys over to the right. So I'm going to subtract m squared, and I'm going to add 4. That will get me, boom, boom, 0. M squared plus 8m plus 12. Okay. Now, I don't like it like this. I don't want my 0 over here. I want my 0 on this side. So I'm going to rewrite it, and I'm going to be super careful because it's an inequality, and I don't want to upset it. The bigger side is this, so I'll rewrite it that way, and this is the same, right? You just have to be careful as you're flipping things around to flip carefully your inequality. All right, now we're ready to factor it, and we've switched over to our other style of problem. This would be what? M plus 6 and m plus 2 are greater than or equal to 0. Okay, now we're just graphing quadratic inequalities like we did before. NBD, this time we want to be greater than 0, so these are either both positive or both negative. This tells me how to set up my charts. I no longer think about this equal sign. I think about making these individual binomials positive, positive, or negative, negative. So in the first one, m plus 6 has to be greater than or equal to 0. You just use whatever whatever form the inequality takes, just copy it to this part of the problem. M plus 2 also has to be greater than or equal to 0. Or we can go the negative, negative route. M plus 6 is less than, and m plus 2 is less than. All right, algebra sticks to fix this. Okay, now this is the style of problem. This is the greater than, so we know that they're going to condense together, right? If it's less than, it's one or the other, and if it's a greater than, it's both of these combined. So I know I'm going to need minus 6, and I'm going to need minus 2. This one, they have to be greater than minus 6 and greater than equal to minus 2, so I'm going to go here. And I want to color that in, but then I stop and check and go, aha, I cannot include minus 2 as part of my answer, so I have to leave that an open circle. This tells me to color it in. That tells me don't you dare. Over here, n has to be less than -6 and less than -2. So I can't use these. I have to wait till I get down here. And this one I can color in because I do have the equal sign and there's no drama. There it is in all its raging glory. The last example of the year. I'm happy about it. I'll tell you what, I like these problems and I will probably throw one of these on the test. I will go through and let you know. I'll make you a review video. That's what I'm trying to say. But I just want to tell you right now, as you're doing these problems, I really like these because they're not that much harder than what we've already done. You just have to remember this nifty little trick of multiplying twice. All right, guess what? The end. Oh, I don't have any space to write it. I'm going to write it here. We are done with this wacky year and a half of COVIDese math. But we did it. I'm very proud of you. We survived. And now, all you have to do is take a final exam. Easy. See you next time. Well, the next time will be the review video. There will be no next lesson. Until next fall. Okay, bye.